everyone, welcome back to my channel. Hope you all are doing good. Now we are going to talk about the classification part or the classification algorithms of supervised learning. And without delay, let us start with our topic. So let us understand more deeper way on how classification works, classification algorithm works. So let us understand what are the types of classification algorithm. Before moving ahead, what is a classification algorithm? Why it is coming into picture? We understood about regression algorithms, right? So we understood that in case of regression algorithm, it is based on the continuous kind of data, right? Here, in case of classification, at the same moment, we saw that it is based on the discrete amount of data or the discrete kind of data. So when we're talking about discrete data, discrete is itself means it's a different classes. Like the output is not limited to a continuous variable. It has different classes. Some examples I want to give. One, just take examples of yes or no, true or false, male or female, survive, not survive. So these cases are your discrete data. So classification algorithms are based on those kind of data. And like I already mentioned, these algorithms are helping to predict the categories, not the continuous numbers, right? And depending on how those categories in your target variable it is divided into most specifically into two categories. One is a binary classification types of algorithm and a multi-class classification types algorithm. Binary classification, as the name says, the target variable, okay, the target variable or your dependent variable or the output, like to which the like I mentioned it, cause and effect. So the effect or the cause for which the effect is happening, right, that is going to be your binary classification. So it has two different kind of possible outcomes. In multi-class classifications, the same target variable or the dependent variable will be having more than two categories, or you can say 3 or 4 or 5. We don't know. So, like I mentioned, binary classification, it's a survive, not survive, the yes or no, spam, not spam. These kind of cases are the binary classification, and the same was mentioned in this image. If you'll see, let me just maximize it. The same was mentioned, like here you can see it's a spam, not spam, positive, negative. Then in case of multi-class classifications, like we have digit recognition, then sentiment analysis, where we are talking about like when we're trying to understand the customer churn, right? The customer, how the customer likes the product. And you must have seen, even you must have received most of the times that the feedback form, right, for each and every product or for each and every applications when they are performing this A/B testing, right? A/B testing I have already explained you. The A/B testing, when they are performing, they will share you the feedback, and the maximum, based on the maximum number of feedback, they will try to keep one kind of application, or they will retain one kind of application and they will modify the other one which the customers does not like, right? So that is your sentiment analysis. And if you see the feedback form, you will be receiving different kind of emojis, and those are your multi-class classification. Those are based on your multi-class classification. Similarly, we have animal detection, right? Animal classification, animal detection, dogs, birds, cats. Those kind of things are again your multi-class classifications. Then here I am trying to explain you on the pictorial form on what are the type of algorithms which we are using in our day-to-day machine learning process. So we have and these all are very important, guys, okay? So we have logistic regression. As the name says, it's not a regression, however, it's a classifier. It's a binary classifier. Mostly it is a binary classifier. Even the same logistic regression is having multiple multi-class classifier as well. I will explain that in our upcoming slides. Then we have tree-based models, which are decision tree, random forest. Okay, then k nearest neighbors. Okay, then support vector machine, Naïve Bayes, then bagging, ADA boosting, gradient boosting, and XG boosting. So these are our ensemble methods, and random forest is a bagging method. Is a bagging ensemble method. We'll understand everything in our coming slides. So first we'll understand about logistic regression. I am explaining all the, or I'm touch basing the basics first now. And when we'll move ahead with our, more videos or more concepts, we will understand each and every concept in a more deeper way. And there I will explain you on which accuracy method you have to use, what is the actual factor which is driving that particular algorithm. So all those things I will explain. But here let us understand the basic, because fundamentals, understanding the fundamentals is a core idea, right? So let us understand about the logistic regression. As it was mentioned, logistic regression applies to both binary and multi-class. And logistic regression is useful for the classification problem most of the times. However, the name was mentioned as a regression. Okay. And we have a category called multinomial logistic regression, which handles the multi-class problem of logistic regression. And what it does, it helps to predict the probability. It depends on how the probability of an event occurs, and based on that, it is going to give you the category related to that. Here one example it was shown. So in this example, what is happening? So in a class, okay, consider that a student, you need to predict whether a student in a class is either going to pass or fail based on the number of study hours. So here what is the event which is occurring? The event is the student has to study for some X hours, right? And here the study hours is our feature, right? And the result is our classification, or the classification, or whether it's a pass or fail class you need to predict. So what logistic regression is doing, it will understand the trend on how the study hours is affecting the result, and it will give you the probability. For suppose 75% chance that the student will pass, 25% chance that the student will pass, like that. And it will come to a final conclusion on the output, whether the student will pass or fail, the final one. Like suppose you are passing a new data set or a new study hour for a new student, it will tell you from the past historical data or the past probabilistic conditional probabilities it is applying, and on that it is going to tell you the output. Now we will understand on how Naïve Bayes classifier works. Naïve Bayes algorithm is based on Bayes theorem, and it is completely depending on predicting on the probability of a given instance and which belongs to the specific class. For example, here I want to give one real time example, and if you see here, right, imagine if you want to predict whether an email is a spam or not spam, because here it is completely depending on how Bayes theorem works, right? And Bayes theorem works on whether a particular event occurred and how that particular event occurred, and based on that it is going to detect that specific class. So here you are getting so many mails, right? So in those mails, how we are going to understand whether that's a spam or not spam? We are going to detect some of the keywords or some of the words. So here we are saying, okay, win, offer and free, these are the words. If the email is containing these words, then we are going to detect that email, or we are going to classify that email as a spam. And if these words are not there, then we are going to classify that email as a not spam. So how it is going to do? It is going to consider, you can see here, it is going to consider the probability of getting spam or not spam with the words in email. So it will check each and every word. And it is again depending on how, like, all these emails which it has received, it will first check all those emails and all those words, each and every word, and it is going to classify that. With that, the learning rate is increasing of this classifier, right? The learning rate is increasing. And with this, as it is depending on all the events occur, like it is going to check all the kind of emails which has been received, and it is going to check each and every word. You can see it is checking each and every word, and it is classifying internally, right? It has the higher probability, like it will predict the class with a higher accuracy. That is why Naïve Bayes is useful in case of your image recognition, in case of your voice recognition, then this spam filter, all these kind of applications, it is very useful, right? Then even in case of in most of the cases, this recommendation engines are using these kind of classification algorithms, few of the cases, right? Now we will understand k nearest neighbor, very important, this one. And what is a k nearest neighbor, guys? And before moving ahead, this k nearest neighbor algorithm is applicable for both binary and multi, and it is applicable for both classification and regression problems. And classification and regression problems, and mostly these classifications are happening with a majority voting. Right? Majority voting or voting classifier, when we are talking voting classifier. So all kind of voting, because when we are talking about classification, what is the basic thing which is happening here? That we are segregating or grouping all the data points or the data set values. And when we are grouping these data sets, what is happening? It will predict, each data set will predict, and everything is a black box, we cannot see that. It is happening internally. So it is going to predict the output for each group, and whichever is accurate, which group is having a more accurate result, it is going to take that and it is going to give you the output. So here voting comes into picture in most of the classification algorithms. So similarly, KNN is based on the majority voting concept. And let me show you in a whiteboard how exactly this KNN works. So let us see. Let me draw few features here. So this is one feature, and this is another feature, and this is how we are understanding our features, right? And these all are vector presentation of features. So this is a feature 1, and this is your feature 2. Okay. So when I'm talking about features, each feature will be having some kind of data, right? So what feature 2 is having? It has few shapes like this. It has some cross shapes. It has some cross shaped data. This class is containing cross, and this class is containing circles. This feature 2 is containing, feature 1 is containing circles. So these are my existing data, right? These are my existing data. So how it works, okay, so how it works, suppose I want to know, like I am giving a new data point, okay, or I am giving a new data set and I am putting it here. This is my new data set. So when I'm putting my new data set here, what exactly is happening? It is going to take, so in case of k nearest neighbor, right? K nearest neighbor, what exactly is happening? First point is we are defining a k value, and k value is how, like, is the value on which it is going to predict the output, or like it's a similarity, or it's a similarity factor, I can say. So we have to define a value. So I am defining a value here as 3. Okay, so when I'm defining this value, what exactly is happening? It will search, okay, which are nearest to me. And how it will search? It will search with Euclidean distance. We know each and every data point will be having x1, y1, and x2 and y2. And we just need to apply Euclidean distance formula. And when that distance it will apply, it will create a, like, or it will identify 3 nearest data points for it. In this image, you can see it found this point, and this point. So what is happening? What are the outputs I got? I got one circle, another circle, and one cross. And like that, whatever the new data points will be coming, okay, whatever the new data points will be coming, it will try to create a near or nearest neighbor. It will try to find out, like this. Then for this, like this, and this, like this, it is going to find. So what exactly is happening? After finding this, it is going to vote which shape or which data point similarity is more. So here I have 2 similar points as compared to 1. So here my circle is having more similarity as compared to my square, or sorry, my cross. So when it found that, okay, I have the more similar values present, it is going to define, okay, this is my predicted class, or this is my target value or target class. So here my target class is O shape, right? So whatever input we are providing, it is going to tell, okay, based on all the features which you have, this is the nearest, or this is the most accurate class which we are able to find out. And this is how your k nearest neighbor works. Let us understand the next points. So here again the same things have been explained here. One more example they have taken, one, how the students' study hours and exam results are interrelated together. Okay, so you can see that the more study a student will do, or the more study they will perform, or they will perform better. The more they will study, the more better they will perform in the exam. And that's a completely linear relation among those 2 points, right? And when it is going to tell, okay, most of the students are getting passed due to the study hours, it is going to consider that okay, that student is passed. So that is what your k nearest neighbor. Then we have support vector machine, one of the very important algorithm. Support vector machine is applicable for both binary and multi or multi-class. And what exactly it is happening? how it works is like when I'll give you one example. I think it will be clear to you. When a child goes to the market, okay, and that child does not know, okay, which is this fruit, because if you see in a bucket or in a container, there will be so many fruits, right? Similar type of fruits, dissimilar type of fruits. So they will see, okay, which is okay, this is a strawberry, this is a strawberry, which is what, or which one I have to take. And again, there is a confusion comes when it's a similar kind or dissimilar kind, right? So in those cases, your support vector machine comes. It will create a hyperplane. Like the algorithm creates a hyperplane or a decision boundary that separates the data from points of different classes. It is going to create such kind of plane, and I will show you in a imagery how it is going to look like. And there are few steps in support vector machine. First, it has to find the hyperplane, okay, that separates the class. Then after that, it is going to maximize the margin between the hyperplane and the nearest points. Okay. Then after that, we need to classify the points on which side of the hyperplane that fall. Like what is the maximum number of points comes on which side of the hyperplane. And the closest points to the hyperplane is going to be the target variable or target class, which you are going to consider. Now, let me take you to the whiteboard and explain you how it works. So, suppose this is my plane. Okay. This is my plane, and this is one feature. This is another feature order. So, when feature 1, feature 2. When we are talking about support vector machine, what exactly is happening? So, here again, we have few shapes. Consider that we have shapes, okay. I'm just creating the same example I'm taking. How we are going to find out. So, we understood about k nearest neighbor. Now, we are going to understand how the support vector machine works. So, we have different kind of shapes. Okay. And these shapes are one classes, right? And different classes, right? So, like this we have in a scattered manner, right? Now, when we are talking about support vector, what exactly is happening? First, it will create a hyperplane. This is your hyperplane. And it is going to create the support vector for that around it. So, this dotted line which I am creating is your support vector. These are your support vectors. And why it is creating the support vectors? To know or to identify the correct class or the correct classification, how it is going to. And this is the total length, or this is your total margin which we are talking about. And there is one term called kernel function. Okay. Kernel function. All these, like when it is creating a hyperplane, that hyperplane is based on the kernel function, and this is a factor which you are going to give input when you are creating or when you are applying the algorithm. So this kernel function, I will explain you when we'll understand more deeper all these features, all those properties, and all these accuracies, how to calculate accuracies for all these cases. I'm going to explain everything. I'm not going to leave any bits. So when it is creating a hyperplane, during that time this kernel function comes into picture, and to support that it will create support vectors, and these are the support vectors. And what it is going to do, it will shift either side. You can see it is shifting either side, this side and this side. Why it is shifting? It has to find out the correct classification. And how it is going to find out? See, if you'll see, it is here I have very few points, right? When it will shift towards this, so here I can see I have 1 and 2 points at it. And when it is shifting here and it is coming on this line, you can see that now that points are increasing. Now it is 4 points coming, 4 or 5 points coming. Similarly, it will move, and when it will move, you can see one line it is shifting, or it is trying to find out which place or which position is correct for me. And you can see that I have around 5 points, or 1, 2, 3, 4, 5. So, like that, it is going to find out the correct class or the correct position, and it is going to tell, okay, which class. Again, here voting comes into picture. Which class is having more quantity or more numbers, or which is the closest one to the support vectors. And that is how your support vector machine works. Now we will understand on decision tree. Very important concept. And what I would suggest to all of you, that whenever it is coming to regression, just understand about linear regression, all properties, how it works and everything. We have scikit-learn, library, and you can go and explore those libraries whenever you have time. However, when it is coming to classification, you need to take one particular algorithm and you need to work on it. You need to understand each and every aspects of it to make it, or to understand more about classification. So decision tree and random forest, these are two important classification algorithms which we are using mostly. So let us understand about decision tree. So decision tree again is used for both classification and regression, and it is applicable for both binary and multi. We can predict all, but most of the times we are going ahead with multi. Binary logistic regression we are following. So it works like a flow chart. Like, let me just draw it here. If you want, like, okay, let me draw it. And so if this is how it works, and how your flowchart works, guys. This is how your flowchart works, right? Flowchart is always based on conditions. It's a condition or conditional parameters, correct? It's your conditional parameters, and you can see this like this. This is how your condition works. So when we are talking about decision tree, what it will do, it will take the factor or the features. Suppose, one example I want to give you which will make your concept completely clear. So in a organization, okay, every year appraisal is happening, okay, and employees are getting their increments. And most of the times you must have heard that, okay, the people who have less experience, even they are getting more. And the people who have experience, they are getting average as compared to the, low experience people. How it is happening? What they are doing, they are applying these concepts, because there are 3 factors. One is age, one is salary, okay, and one is experience. So what it will do, they will take all the existing data, and they will apply these decision tree. How it is going to happen? Let me take you to the whiteboard and explain it. So what is happening here? Where we have, okay, age, salary, existing. These are all past data, okay, and the experience. So what is happening? First, it will take. So there are, there is a saying, right? I mean, if more experience, then the people must be aged, right? So we have few criteria how the algorithm understands Okay, if age, it will take if age is greater than 30, that means that person is more experienced. So it will first take if age is greater than 30, then it will segregate. What it will do? It will tell that, okay, one factor that, the person will get more salary and the person will get less salary. More salary, less salary. Then again, it is again depending on experience. So here it found out the condition now based on the experience. If the person is having experience in so and so skills, right? I mean, consider that some have .NET, then some have Java, right? Then some have like they will take, consider that if a person is having 8 skills, experience in 8 skills, they will get more salary, and the person who is having 6 skills, they will get less salary. Then again it will segregate salary. More salary when they will get 8 skills, less salary if it is more. Similarly here it will tell, okay, less salary if it is 6 skills, more salary if it is not, right? So like that, it is going to simplify the concepts, and this is how your tree structure comes into picture. When we are talking about decision tree, it is based on the tree structure. Now we'll go to the slide. So here, right, when we are talking about tree, each node is called a leaf node. Like we have a main node, then we have a leaf node. So you can see in this image, we have root node, we have interior node, then leaf node. So again, whenever we are talking about tree, it is based on true or false. If it is true, something will happen. If it is false, something will happen. So like that, this algorithm simplifies the data, and there is a disadvantage on this algorithm, which is nothing but if you'll understand, like when I'll show you the algorithm application of this algorithm on the real data, you will see the accuracy level is coming around 99 to 100%. So when the accuracy level is coming very near to that, that means logically the machine or the model or the algorithm is trying to make the model lazy, or it is trying to simplify the structure in such a way that the model is unable to learn from the data. It is not able to understand, it is not able to learn, it is just memorizing the data, and that's where your overfitting concept comes into picture. So decision tree algorithms are more tend towards overfitting. To avoid that scenarios, or to avoid those scenarios, we have two concepts. One is called bagging and another is boosting. And bagging and boosting are your ensemble techniques. And what is ensemble technique? We saw when we are working with decision tree, for a single decision tree, it has more chances for overfitting. And to avoid that scenarios, to avoid and to increase the learning rate of the models, it is helpful to combine more than one models, and it will give you the good prediction, right? And that is where ensemble technique comes into picture. Ensemble technique is, the combination of more than one model. Okay, we will understand in this slide itself. One of the example is your random forest. Random forest, the base model here in case of random forest is decision tree, and like the name is saying, random forest, that means it has multiple decision trees. It will predict the output from multiple decision trees. And again, it is applicable for both classification and regression. We can apply, or we can solve both kind of problems, classification problems and regression problems. And the ensemble techniques which is using is bagging, or bagging is called as bootstrap aggregation. What is the concept? Let me take you to the whiteboard and explain. So before moving ahead to the whiteboard, like I mentioned, that a single decision tree is more, it learns the patterns well because it is understanding the logic, and it is simplifying the logic by, yes or no, and putting the conditions. To avoid that, we are going ahead with over a random forest. And let me take you to the whiteboard and explain you on how bagging works. So when I'm talking about random forest, okay, we will be having a factor called n estimate. That is the first one, n estimator. That is one. Then second is your bootstrap. As we are using the bagging, the bootstrap will be there. Bootstrap. So bootstrap, again, you have to define a bootstrap factor here. So how it is going to work? So it is going to create, different kind of subsets. So consider that you are defining the number of decision trees, or an estimator you are giving 100. That means it is going to create a subset of 10. Take one example, it is going to create a subset of 10. So what exactly is going to do? It is going to create a subset of 10 like this. This is one decision tree. Okay. This is another decision tree. Right? Like that, it is going to create different kind of subsets. And each subset is called as a bootstrap subset or bootstrap aggregate. Okay, this is 1, this is 2. Like that, it is going to create 10. And what exactly is going to happen? All the things, like everything, they are going to add weight. For example, because each and every subgroup is going to predict, right? So here, consider that it predicted wrongly, and this one also predicted wrongly. So what is going to do? It is going to add higher weights. Suppose they are adding weights. Okay. Then in the third subgroup which we have, suppose it is going to predict correctly. That means the weight addition will be reduced. They are getting kind of rewarded, right? So like that, the final output is going to be on such a way that where the bias or the weight addition is less, or the variance is less, in those cases, it is going to tell you the final output. Like after complete refinement of all these things, and all will happen at a time, and it is going to give you the output based on that. So like I mentioned, it is based on understanding the bias or reducing the bias. How it is going to reduce? Because whenever it is predicting wrongly, it is adding weights, and each time whenever it is adding weights, it is being careful. Okay, I need to be correct on the next time, and like that, it will be one point of time will come where the weights or the bias will be completely nullified or completely zero. At that time, the prediction will be correct, right? So it will be considering the final one. So that is how your bagging concept works. Okay. And random forest, like I mentioned, is using the same concept and it is working. Here again, the same logic or the same concept which I have explained there. Bootstrap sampling or bootstrap aggregating. Bagging is again shortly called as, and it's an ensemble technique. Like again, I mentioned what is ensemble technique. It is a combination of more than one model, right? Then these are the steps, like I already mentioned. Like it is going to take the majority voting, like it will reduce the weights, and it keeps on reducing the bias. Then finally, it is going to predict the output. Okay, so that is how your bagging works. Then we have ADA boosting, right? Now we understood bagging. Now let me take you to the whiteboard and explain you how the ADA boosting works. Like the name is there, right? ADA boosting means adaptive boosting. Again, it's one important ensemble algorithm. What is the logic behind it? Is it like whenever we are saying okay, ADA boosting, you need to remember one thing, that multiple weak learners are going to create one strong classifier. Multiple weak learners are going to create a strong classifier. And why that concept is coming? Suppose in a class, a teacher is like, there are a group of 10 students, okay, who are like, out of that, few people are strong learner and few people are weak learner. Okay, so a teacher, what they will do, they will give a 10 questions to those students. What they will do, for the first student, they will go and they will see the answer, whether they have how they have performed, whether they have answered all 10 questions correctly or not. If all, and the teacher will try to understand the mistakes, or they will try to understand whichever, like what are the questions that first student made wrong. Then they will go to the second student and they will ask that second student, focus more on these questions and I need correct answer on the next time. Even the second student, consider that 5 questions are right and 5 questions were wrong. So that second student is focusing on another 5, like the wrong questions, and they will, like the second student is also failing. Then again they will go to the third student and they will try to do the same thing. Like that, one final student will come who can memorize well or who can learn well, and that is the same concept in case of boosting. Here everything will happen sequentially, and let me take you to the whiteboard, and it's the same concept, guys. It's the same concept, and mostly it is happening on your decision trees. Mostly it is happening on decision. It will work well with the decision trees. So in our previous example, what we saw, that it is creating different groups. Here also it is going to create different kind of groups. Okay. However, there all will happen automatically and the majority voting will be coming into picture. Here, this is one group. Okay, similarly, this is another group I'm creating. So, this is another group. This is another group and this is another group. So, like that, it will create different groups and each group will predict the outcome. Each group will predict the outcome, and those outcomes, it will predict the outcome. And when they're predicting the outcome, if it is getting wrong, it is adding the weight. It is adding the weight, and or it is completely based on the, like the name says, right, gradient boosting. It is going to control the errors, and based on that it is going to add weight. So there it is based on the bias. Here it is based on the error, the amount of error. It will understand, okay, the amount of error, and it is going to add weights. So the next time when it will go, it will try to correct it, and this is getting free. Now the focus will come to more on this. Like it is happening sequentially. It is not happening all together. After one group, it will go to the another group. Then after that, it will go to the another group, and like that, this weight addition, then reducing the error, all those things will happen, and finally it will create a better classification, and that is how your boosting works. Same concept, both are same concept, bagging and boosting. However, in case of bagging, it will be based on bias. In case of boosting, it is based on the errors or the error, the number, the amount of error it is going to consider, and it is going to reduce it, and it is going to give you the final output. Okay, so we understood on how this adder boosting works. Same thing, guys, like the way I have explained, it gives more weight to the data point where the misclassification happened, right? And we have something called XG boosting. What is XG boosting? XG boost is a extra gradient boosting. So here it's adaptive, it's a XG boost. It's everything is same case, guys. Like here we are adding weight, here we are adding and understanding the error, and everything is happening sequentially in case of boosting, and in case of bagging it is happening all together, all at once. So when we're talking about gradient boosting or extreme gradient boosting, again it's traditional. Extreme refers to the enhancements made to the traditional boosting to make it faster and more accurate, and it is good for the larger data sets. It is good for the larger data sets. How it is working? Like the way I have explained, it is going to create different kind of subgroups. Then it is going to predict each one, or each group is going to predict the base prediction it is going to do. Then after that it is going to calculate the errors, the amount of errors. Then it is going to train the next one. Then it will add the next one to the model with the weight, okay, to improve the prediction. Like that it is going to happen. So everything is weight, bias and errors, okay, in case of bagging and boosting. And this is all your supervised learning and classification methods or classification algorithms explained. And we will understand our further topics in our upcoming videos. I'm going to start with simple linear regression and all the concepts attached to that. And till that time, see you. Bye. So we understood about classification algorithms and its use, and this is very helpful in your interview, because all questions, whatever questions which are going to come from interview are going to come from these topics. So go through these videos, understand each topic. Till that time, see you. Please start subscribing, like, share your comments, share your feedback, share this channel into all your friends and near ones. Till that time, see you. Bye. Take care.